which is okay, but just don't say the Sunday night before we come back from Christmas vacation, I hate Mr. Park, he gave us homework. I didn't give you homework. All right, so it looks like, oh, now we're gonna graph point by point. Okay, you know what? I would do one problem from number 1 and one problem from number 2. And look, I give you specific directions. So number 1, it says graph from 0 to 2 pi, and theta step is equal to pi over 4. What does that mean? That means you're gonna plot a point every 45 degrees. I'm telling you exactly what to do. Okay, which one looks interesting? Okay, let's do B. R equals 1 plus sine squared theta. Or maybe we should do number 1. Yeah, let's do number 1. Cosine squared theta. Okay, now is that a base graph? Remember we learned base graphs yesterday? Was that one of the base graphs? No, so you can't use that method. What about changing it to a rectangular equation? Yeah, you can change it to a rectangular equation, but you're gonna find out, I don't know how to graph that. In fact, just for funsies, let's just change this to a rectangular equation because you might see this on the test. You might have to change it. Okay, what can I do to both sides of this equation to change it to x's and y's? I'll give you a hint. X equals r cosine theta. Well, this is cosine squared, so multiply both sides by r squared. Okay, good. So you get r cubed is equal to r squared cosine squared theta. So what is this? That's x squared, right? R cosine theta times r cosine theta. But what about this? In fact, I think I gave this on a test once. Isn't r cubed the same thing as r squared to the 3/2 power? Multiply the exponents. And then r squared is equal to x squared plus y squared. There you go. That's the rectangular equation, except who even knows how to graph that? Not even I know how to graph that. So that's not an option. So what you need to do is you just gotta plot points. Okay, so I'm gonna give you specific directions. 0 to 2 pi every 45 degrees. So basically you're making a chart. Okay, so you're gonna have one problem like this on the test. Not on the quiz, on the test. So what you might want to do is draw like a circle of radius 1. Okay, how do I know the graph is not going to go past 1? How do I know the whole graph is going to be inside the circle of radius 1 here? Because what's the biggest cosine ever gets? 1, and then you square it, you get 1. So that r represents how far you are from the origin. So you will never be more than 1 unit from the origin. So all the graph will be in here. Okay, here we go. Start at 0, plug in 0. What does r come out to? 1. 1 squared is 1. Okay, pi over 4. Or 45 degrees. What is cosine of pi over 4? Remember, cosine squared theta means cosine theta squared. That's what it means. So 1 over root 2 squared. 1/2. Okay, pi over 2 now. 0. 3 pi over 4. 1/2, because it's negative 1 over root 2. You square it, you get positive 1/2. Pi. 1, right? Because cosine of pi is negative 1. Negative 1 squared is positive 1. 5 pi over 4. 1/2. 3 pi over 2. 0. 7 pi over 4. 1/2. And then finally 2 pi. Okay, good. 1. Okay, now do you remember the order that we plotted these points? 1, 2, 3, 4, 5, 6, 7, 8, 9. Connect them in order. But you got to remember, do not connect it with straight lines because it goes gradually from 1 to 1/2. So it's more like this. Because remember, polar coordinates, it's how far you are from the origin. See how the distance from the origin goes gradually from 1 to 1/2. Okay, and then gradually from 1/2 to 0. Then gradually from 0 to 1/2. 1/2 to 1. 1 to 1/2. 1 to 0. 0 to 1/2. 0 to 1. And there. So the graph is like these two blob-shaped things. Easy, yeah? So it's easy when R is positive. It's really easy. Okay, but there's one problem on tonight's homework, I think. R becomes negative, and then remember, negative, you gotta go on the opposite side now. So you really need to practice that one. And which one is that? That's 2C. Okay, I'm gonna do a problem from 2, but it's not gonna be C. And it's not gonna be A or B, because I want you to think about that. So it's gonna be D then. We will do D. Hey, this looks like a problem I gave last year. Maybe I changed it to minus or changed it to cosine or something. Okay, now read the directions to this. This one you gotta graph 0 to 4 pi. So that means you gotta go 2 times around. Sometimes you have to go 2 times around to get the entire graph. Now remember, on your graphing calculator, the default setting is from 0 to 2 pi now. So if you wanna check your answers for number 2, you have to change the plot settings from 0 to 4 pi. Otherwise, you're not going to see the whole thing. Okay, so plot a point every 90 degrees, but 0 to 4 pi. Okay, now this one, you're going to need 2 units. What could be here? Let's do this then. 1, 2. I'm trying to make it accurate. 1, 2. Oh, don't break! 1, 2. Hagoromo chalk is expensive, that's why. You guys ever heard of Hagoromo chalk? Yeah. Okay, I'm not gonna make the concentric circles. You know why? Because we're plotting a point every 90 degrees. We're not gonna be plotting a point at 45 degrees, so no need. Okay, let's see if we can do this. Plug in 0. What does R come out to? Basically, you're making a chart, but you're just doing it in your head. Okay, I think we can do that. 0. 1, right? Because 0 over 2 is 0. Sine of 0 is 0. 1 plus 0 equals 1. Hopefully that can be done in your head. Okay, pi over 2. Uh-oh. What is pi over 2 over 2? Huh? Pi over 4. Pi over 2 over 2 is pi over 4. What is the sine of pi over 4? Root 2 over 2, which is about what? Okay, remember, root 2 is approximately 1.4. Root 3 is approximately 1.7. You need this information to graph. So, what would be root 2 over 2? 0.7. Okay, so 0.7 plus 1 is 1.7. So, about there. Okay, now, do you want to like plot all the points first and then connect it, or you want to connect it as you go? Doesn't matter to me. Maybe, okay, this one you're going to have plenty, well, I don't know. Why don't we connect it as we go? So it's going to go gradually from 1 to 1.7, like that. Do not draw a straight line. Okay, pi. Plug in pi. I don't think I heard it yet. 2. Because look, pi over 2 sine is 1. 1 plus 1 is 2. So it's going to go from 1.7 to 2 gradually. 3 pi over 2. I guess this is the hardest part. Looking at the, huh? Okay, look. 3 pi over 2 is 3 pi over 4. Sine. root 2 over 2, which we already established is 0.7. So what is 0.7 plus 1? 1.7. Okay, now 2 pi. 1. Look, what is 2 pi divided by 2? Pi, sine of pi is 0. 0 plus 1 is 1. Oh my goodness, you guys are going to have a really hard time when we get to the negative one. Okay, now we're going to keep on going. So we got to go around one more time. 5 pi over 2. Okay, step by step. 5 pi over 2 divided by 2 is 5 pi over 4. Sine it. Negative root 2 over 2, which is negative 0.7. So negative 0.7 plus 1. Okay, now it's 0.3. Okay, so it's going to go gradually from 1 to 0.3. Okay, now we're at 3 pi. Okay, what is 3 pi over 2? 3 pi over 2. Sine it.
0.
Negative 1. Negative 1 plus 1 is 0. Okay, so it's going to go from 0.3 to 0 gradually. Okay, where are we now? Oh, we're here now, right? 7 pi over 2. 7 pi over 2 over 2. 7 pi over 4. Sine it. Negative root 2 over 2, or negative 0.7 plus 1. So it's going to be 0.3 again. So it's going to go from 0 to 0.3, and then finally 4 pi. 0 plus 1, 1. So it's going to go from 0.3 to 1, and there you go. Isn't that a neat graph? It's like you have a blob with an inner loop, but the inner loop is a cardioid. Isn't that neat? So, like I said, you're going to have one of these to do on the test, which is when we come back from vacation. So this stuff here is not on Thursday's quiz now. This is just tonight's homework. Okay, number 3, I'm not going to do any of those. I think it's better if you learn this example here. So r equal 2 cosine theta, r equal 2 sine theta. So just like in Algebra 1, after you guys learned how to graph lines, right? What did you guys do after that, after you learned how to graph lines? Did you find where they intersected? That's exactly what we're going to do now. Now we know how to graph polar graphs. How do you find where they intersect? So that's what you, now look at the directions. Graph and find all points of intersection between 0 and 360 degrees. Okay, now what should I do first? Should I solve the equations algebraically first and then draw the graph, or should I draw the graph first and then solve it algebraically? What do you think? Okay, I'll just tell you. Solve the equations algebraically first. Okay, now how do I solve these equations? No, we're not changing it to rectangular. We just want to solve, right? Just like, okay, when we did Algebra 1, you either got 2 choices. You got elimination or substitution. Okay, substitution. So since r equals this, can't they substitute it for r? So you got 2 cosine theta is equal to 2 sine theta. Divide both sides by 2, and you get cosine theta equals sine theta. Okay, this is now you got to be able to solve trig equations, which we did a couple chapters ago, right? When is cosine theta equal to sine theta? Just think about it. Where on the unit circle would cosine equal to sine? Pi over 4 and 5 pi over 4. Because at pi over 4, they're both root 2 over 2, right? And then at 5 pi over 4, they're both negative root 2 over 2. Now, if you don't like that thinking, then how about divide both sides by cosine theta? Divide that by cosine theta. 1. Divide that by cosine theta. Tangent theta. When is tangent theta equal to 1? Pi over 4 and 5 pi over 4. If you don't like that explanation, divide both sides by sine theta. Divide that by sine. Divide that by sine. When is cotangent theta equal to 1? Pi over 4 and 5 pi over 4. So no matter what, It doesn't matter what you do, you gotta get this. Now, you gotta find the points of intersection now. These are just the theta coordinates, so your actual points of intersection, these are the theta coordinates. How do I get the r coordinate? Yeah, you plug it back into one of these. It's just like rectangular, you do the same thing. So which one looks easier to plug into? To me, they both look the same. Let's do this one then. What is the cosine of pi over 4? Root 2 over 2 times 2? Root 2. Okay, what is the cosine of 5 pi over 4? Negative root 2 over 2 times 2. Negative root 2. There you go, those are your points of intersection. Now we got to draw the graphs. Now, for this kind of stuff, I'm only going to give you base graphs. So hopefully you did your homework. Like, hey, you're going to have to do this tomorrow. In fact, if you do number 3, that's good practice for Thursday's quiz. What is this? Rhymes with Hercle. It's a circle. Diameter 2. Remember the number in the front is the diameter? What is that?
Circle.
It's a circle. Diameter 2. Let's draw it over here. I'm going to erase this stuff here. Okay, so how do you graph? Remember? I hope you guys remember. You're going to have to do this on Thursday. What did I tell you yesterday? What's the fastest way to graph the circle? How many points should I plot? 2 or 4?
2.
2. 0 and pi over 2. Plug in 0 into this.
0.
You get 2. Okay? Plug in pi over 2 into this.
0.
Then you get 0. You see these 2 points? That's the endpoints of the diameter. So you got a semicircle on the top and a semicircle on the bottom. The top one looks too flat. Okay, a little bit better. Okay, now let's graph this circle. Plot 2 points, 0 and pi over 2. What happens when you plug in 0? 0. What happens when you plug in pi over 2? You get 2. It's up here. So let's see if I can draw a circle. Okay, so that makes sense, Mr. Parkins. Look, got 2 points of intersection and then got 2 points here, yeah?
No.
Or does somebody see something wrong? Okay, let's check. Okay, how do you plot this point? You measure off an angle of 45 degrees and then you go root 2 from the origin. So if I measure off an angle of 45 degrees and go root 2 from the origin, right there. Okay, that's that point then, yeah? So the other one must be this one then, yeah? No move spread. Because what do you do here? You measure off an angle of 5 pi over 4, that's over here, and then you got to go root 2 in the opposite direction. Hey, that's this point again. How come this point came out twice? You guys remember what I told you yesterday? Apparently not. Okay, how do you graph circles from 0 to 2 pi? Remember I told you, it's not enough to draw the graph. You have to know how it's formed. Okay, here. If I'm the calculator, I'm going to graph from 0 to 2 pi. This is how it goes. 0, pi over 2, pi, 3 pi over 2, and then 2 pi. You guys remember that? It goes around twice. And then, what happens when you graph the sine one? 0, pi over 2, pi, 3 pi over 2, 2 pi. Circles, if you're going to graph from 0 to 2 pi, they actually go around twice. Now, what would happen if you graph both of them at the same time? Okay, let's attempt this. Do not attempt this at home. Go. See, that's pi over 4. Then pi over 2. Pi. 5 pi over 4. See, that's another point of intersection. Where are we now? 3 pi over 2. And then 2 pi. So, in order to be an algebraic point of inflection, they actually have to get to that point at the same time. which they did, right? Remember? Yeah, but you can clearly see from the graph that, don't they intersect right there as well? How come it didn't show up over here then? Because they don't get to that point at the same time. But that's clearly a point of intersection, so you know what we say? I guess nobody looked ahead, yeah? We have to say the pole. Pole is another word for origin, remember, yeah? Pole, the pole is a graphical point of intersection. Now, what does that mean? A graphical point of intersection means the only way you can tell it's a point of intersection is by drawing the graph. You guys get it? It's a graphical point of intersection. An algebraic point of intersection means they actually get there at the same time. Okay, so this is your answer. And every year they say, Mr. Park, do I have to write out the words graphical point of intersection? No. If you want to abbreviate, I will allow it. You can just put GPI. That means graphical point of intersection. That means the graphs intersect there, but they don't actually get there at the same time. So you understand the difference between these two? Okay, now some graphs don't have any graphical points of intersection. So every problem is different. So that's why you have to understand how things are graphed. All right, so like I said, if you want good practice for Thursday's quiz, do number 3. Because these are all base graphs, look. Okay, what is this? Let's practice. This is good practice. What is this 1A1? Circle. Rose curve, how many petals? 4. How come? Because if that number is even, remember you get twice as many petals. Okay, this one. Mr. Parker, after I do the homework, I'm going to get it. That's the monopole, because 4 is bigger than 2. Oh boy. Cardioid. Remember, if this number is the same as that number, you get the cardioid, the heart-shaped thing. Monopole, because 3 is bigger than 2. Inner loop. Remember, if this number is smaller than that number, then you get like the cardioid with the loop inside. No ellipses on that. Lemniscate. The lemniscate. Look, there's only one graph that has an r squared and a 2 theta in it. That's the lemniscate is a figure 8, remember? Don't worry, after I do the homework, I'll get it. Circle. Diameter 2 root 2. So that's good practice. Okay, this stuff is not going to be in the quiz because this is brand new stuff, but just graphing these, that's good practice for the quiz. Because you know I'm going to test you on all of them, right? Oh, and I think we ran out of time during the lecture. Does everybody understand that rotational thing on the homework? You know, the last 4 problems on the, okay, here. Because some of you probably didn't even do them. We're in trouble. Okay, what if you had this? This is good practice for the quiz. How about 2 plus 2 sine theta? Now let's make it minus. Okay, what is this graph going to be? Cardioid, because this number is the same as that. Anyway, you don't need to know that. Just plot the quadrantals. Okay, plot 0. Go. 0. 2. Pi over 2. 0. Pi. 2. 3 pi over 2. 4. And you got to go 4 in that direction now. So, here's Johnny. Yeah. Yeah, it's all right. Okay, so what would happen instead of theta? What if I had a theta minus pi over 2? That was the last 4 problems on the homework. So how does this affect the graph? For those of you who actually did the homework. It rotates the graph. Okay, so that's like pi over 2 is 90 degrees. So if it's minus, do I rotate it counterclockwise or clockwise? Counterclockwise, because counterclockwise is the positive direction in mathematics. If it was a plus, then you rotate it clockwise, because clockwise is the negative direction. Okay, so do you guys understand about rotating it about the origin? Because some people, they don't get it. I need a piece of paper to show you that. I need a piece of paper. Okay, so we got the cardioid on this. Here, let me draw it. Something like that? Okay, so here's the origin. If you put a pin right there, and we rotate it 90 degrees counterclockwise, look. Now it looks like that. You guys know what rotate means? And if that was a plus, then you would rotate it 90 degrees clockwise, like that. You get it? So everything is about the origin. So just like you're putting a pin there. So what does that mean? If you okay, so if I want to do this, that means this point gets rotated over here. 0 just stays at the origin. This point gets rotated over here, and this point gets rotated over there. So now the graph looks like this. So the original graph, the base graph, if some of you still think it looks like a butt, okay? So if you think about it as a butt, then it's blowing north, right? After the rotation, now it's blowing to the west. What does he mean blowing? Okay, whatever. Okay, I am not going to test you on the rotation thing on the quiz, okay? However, you better know it for the test. So on Thursday's quiz, it's just like the homework, okay? It's polar 1 and polar 2. It's just straightforward. There's no tricks at all. But you gotta know your base graphs. You have to. And make sure you know the 4 formulas. All right, no questions? Hey, we finished early. So just remember.